Hello. So our final lecture here on section 8.5, this is on what's called the binomial theorem. And the main purpose of the binomial theorem is to expand a binomial that's being raised to a certain power. And we use something called binomial coefficients. So let's start with that. The binomial coefficient is really NCR, a combination. When we studied probability, not in this class, but earlier, if we have n objects and we want to pick groups of size r, so how many groups are possible, we would do NCR on our calculator. Well, this is really what's called the binomial coefficient. And historically, it's written like this. It's not written NCR. Historically, it's written like this with n and r, but it's identified the same way. So let's practice. 9, 5. So 9C5, or the binomial 9, 5, we would do 9 factorial. Divided by 5 factorial times 9 minus 5 factorial. Well, 9 factorial is 9 times 8 times 7 all the way down to 1. And the 5 factorial is 5 times 4 down all the way down to 1. And then 9 minus 5 is 4. And here's 4 factorial. Well, 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1 just cancels out, leaving you with 1. The 6 can cancel out with 3 times 2. And 8, I could take 8, and 8 has a factor of 4. So if I take out that 4, that 8 is 2 is left over. So really, 9 factorial divided by 5 factorial times 4 factorial just simplifies to 9 times 7 times 2, which is 126. And then 4 factorial, you plug in the values where they go, evaluate, and you get 4. So it's important that we know how to do this on our calculator. Let's do 9, 5. So first with the 84, the nice thing about the 84 is that it's totally free. It's free as an app. It's free online. I have it on my phone, whatever. So, but for the TI-84, it's underneath math and then probability. And there's NCR. But the syntax of this program is that you have to identify n first before you even go to that menu. So n is 9. So you have to press 9 first and then go to math. Probability number 3. And then it spaces it out. 9 is n. Now the r value is 5. So you press 5. And then now we press enter and we get 126. Almost everything is easier on the Inspire. So switching to menu, go to probability and combinations, NCR. So now we have, it was 9 and 5, and the parentheses is indicating to me that's where I put my values in, and the pulsing cursor is waiting for me. So I need to put in 9 and R. And if you just press 9, 5, it's going to think N is 95. So we just separate them by a comma and press enter, and we get 126. Now, we're going to do a couple examples before we define it more mathematically. But if I were to expand x plus 7 to the 5th power, an Algebra 1 student would really bemoan this because they had to do x plus 7 times x plus 7 times x plus 7 times, 5 times. And that would be a lot of distributing, multiplying. You have to be really organized and get your final correct answer of this. But there is a much, much more efficient way by using the binomial theorem. So first of all, what do you notice when you look at this first line? First, we've got binomial coefficients. 5, 0, 5, choose 1, 5, choose 2, all the way till 5, choose 5. And those numbers are corresponding to these right here. 5, choose 0 is 1. So if you go to your calculator and do NCR, 5C0, you would get 1. 5C1 is 5, and etc. The next part I need you to notice is what that's being multiplied to. Right here, it's x to the 5th, but there is no 7. The two terms here, x and 7, the x is being raised to the fifth, but there is no 7. But then on the next term, the x is now being raised to the fourth, and the 7 is being raised to the first. And on the next term, the x is being raised to the third, and the 7 is being raised to the second power. So as you move on, it starts with x to the fifth, and then x goes down 1 power every time until there are no x's. And the other term, 7, starts off with no 7, but then it becomes 7 to the first, 7 to the second. So the 7 grows, and it reaches its maximum at the very end. And that's if you can recognize that organization, then you're going to get all these correct. The rest is just being careful to multiply correctly. So we go to our calculator, you do 5C0, 5C1, 5C2, and you calculate 7 squared, which is 49, multiply everything together, and you get these 6 terms for our final answer. Another example, let's find just the first 3 terms of the expansion here. So here, instead of x and 7, I've got 2x and negative 9y squared. And it's being raised to the 6th. So my first binomial coefficient is 6c0. My second binomial coefficient is 6c1, and then 6c2. Those are the first 3 terms. And then 2x starts off with 2x to the 6th, and then 2x to the 5th, and then 2x to the 4th. And you're multiplying that by negative 9y squared, well, to the 0, so that's just 1. Negative 9y squared to the first, negative 9y squared squared, and then you simplify. Be careful here because this negative 9 to the first preserves the negative, so this second term is actually a minus term. The negative 9y squared squared would become 81y to the fourth positive, so that makes that term positive. So here we can finally define it in a more mathematical way. So for any binomial raised to n, where n is a positive integer, we can express it like this, where the binomial coefficients are n0, n1, n2, n3, n4, n5, all the way to nn. And then a and b, a begins the biggest, so a to the nth power, and then a gets smaller and smaller until there is no a term in the last term. And then b starts off the smallest, but then b grows, b to the first, b to the second, and so on. So let's find the 5th term in the expansion of this. And there's a triangle here, and I want to go back before we do that because that's our last slide. The binomial coefficients are embedded in what's known over here as the Pascal triangle, or Pascal's triangle. So 5, 0, 5, 1, 5, 2, 5, 3, all these binomial coefficients correspond to 1, 5, 10, 10, 5, 1. And that's this row of the Pascal's triangle. Pascal's triangle could be generated by, you start off with the number 1, and then 1, 1, and then 1 again, but then the next number is the sum of these 2 numbers up here, which is 2. And then you end on a 1. You always start and end on a 1. And then 1, and then these 2 numbers, 1 and 2, add up to become 3. These 2 numbers, 2 and 1, add up to become 3. And then we end on 1. And then lastly, 1, these 2 add up to become 4. These 2 add up to become 6, 3 and 3. 3 and 1 add up to become 4. And then you end in a 1 again. So that's how you generate the Pascal's triangle. But that nice little pattern is creating binomial coefficients. And that also occurred with this one. This was 6, 0, 6, choose 1, 6, choose 2. That corresponded to 1, 6, and 15. That is the first 3 numbers in this row, 1, 6, 15. So for this one, since it's being raised to the 7th power, I want to find the correct row, and it is this last row here. I mean, this triangle goes on forever, but the 7th, this row that has a 7 as the second number, this is the key row that I want. These are all the binomial coefficients for a power of 7. This is 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, etc. So if I want to find the 5th term, Well, this is the first term, the second term, the third term, the fourth term, the fifth term. So my binomial coefficient is 35. But then for every term, you're multiplying the a term and the b term. So 4x times 3xy. But to what power? Remember, 4x, the a term, starts off the largest. So this would be 4x to the 7th. This then would become 4x to the 6th, 4x to the 5th, 4x to the 4th, 4x to the 3rd. So 4x is being raised to the 3rd. The second term, 3xy, begins with nothing, begins 3xy to the 0, and then it becomes 3xy to the 1st, 3xy to the 2nd, to the 3rd, to the 4th. And these two exponents, 3 and 4, will always add to the exponent in the original problem. And now it's just a matter of evaluating correctly. You have to do exponents first. So forget about multiplying 35 times 4. You have to do 4x cubed first. That's 64x cubed. And then you have to do 3xy to the 4th, which is 81x to the 4th, y to the 4th. Now you have all multiplication, and you can just multiply all the numbers. 35 times 64 times 81 gives you this monster. X to the 3rd times x to the 4th, I can combine to become x to the 7th, and then you have y to the 4th.